Now that you know how to do Punnett squares and pedigrees, and you know a lot about blood types, we can actually do some exercise about blood types, which for a lot of people is their favorite part of genetics. And I actually have a really cool exercise on that on one of my higher level question tests, which you're going to see later as you go through this topic. But let's do a few of these problems just to warm you up and see what you got to do. So, like, for starters, let's think about what happens when a parent that's AB crosses with a parent that is B recessive for the trait, but it carries the B thing. So this is just a simple Punnett square. So I just wanted to show you how easy it is to make a Punnett square and figure this out. So you're going to make this will be basically the A, this will be the B. So I'm actually segregating the alleles for the first parent, and then I will segregate the alleles for the second parent, and there you go. So now to calculate the children, all you got to do is basically cross, like any regular Punnett square that you've done for the previous chapter, right? So you're going to have one child that's AB, one child that's B in this setup. This one will get the B with the I, so he's going to be B as well. And this one will get the B with the A, and he's going to be, therefore, he's going to be the A type. So you're going to get in this situation a child that's going to be B, a child that's going to be AB, a child that's going to be A, and a child that's going to be B. So you got two children with the B type, one child with the AB type, and one child with the A type. So you can see how you can figure out the ratios of this. So if the question was asking the probability of, say, the O type, you would say 0. If the question was asking the probability of the B type, you're going to say 50%. And if the question was asking the probability of the AB type, you would say 25%, or the A type, same thing. So you see, you can just simply do a Punnett square after you know the genotypes of the parents. But what if you don't exactly know the genotypes of the parents and they try to tell you something? For example, what if it has a word problem that just gives you the information without necessarily giving you the exact genotypes? Well, the best thing to tackle a problem like that is to do a pedigree and then do the Punnett square. So let's see that. Problem says that mom is A blood type. So this mom is an A blood type, and so we have an A blood type mother that marries a dad that is a B blood type. So I'm creating a pedigree over here. Now, the question is asking, what are the possible children of this cross? If both of these parents had parents, at least one parent, that is, that had the O type. So we have at least one parent for both of these with the O type. And now they're trying to ask you, what are the possible chances of the offsprings, the probability of the different blood types of this offspring. So we want to find out the probability of the A type, the probability of the B type, the probability of the AB type, and the probability of the O type for these traits. So let's see what we can do about this. Well, first, you have to realize that if they have one parent with the O trait, what does that mean? That means if you think about and you make a Punnett square for these parents, since one of their parents has the O trait, all they can donate is going to be the I gene. So no matter where you look in the Punnett square, you're going to have an I gene. Right? So that means that the little I is going to be, or the recessive gene for the O type is going to have to be in these people. So they're going to be carriers for the I gene, and that helps me identify the genotype of these parents as this. They must be carrying the recessive gene if one of their parents was homozygous recessive, because that's all that parent could donate. So that means that the other parent would have to be carrying the A type in order for them to be B type to be like that, and the other parent will probably donate the A type in order for him to be like that. So that's kind of how it goes. But now that I know the genotype of both parents, is the same thing we just did, just a simple Punnett square between the two parents, and we can figure this out quite easily. So you segregate the genes, you put the big I with the A, and with the little I, and the big I with the B with the little I. You do a Punnett square, and you figure out that this one right here will be an AB blood type. So this one right here will be a B blood type with carrier for the recessive trait. But since it has a dominant, it's going to show out the dominant trait phenotype. And here again, you have the A type, and you have one where you have the recessive for both with the O type. So the answer would be 25% for each of those genes. Each of those phenotypes has a 25% chance of occurring. So there it goes. Yet another one of these genetic problems. Not that hard to figure it out. So sometimes what they would do is that they will give you the problem backwards. They won't tell you much about the parents, but they'll tell you a lot about the children. So for example, in this case, they tell you that two parents who are different from each other, so they do not have the same blood type or phenotype, married. And they also tell you that the mother is not the A-type. So you know one thing for sure, the mother is not A-type. And you know that they had several children. And that no matter how many children they had, they always got either AB or they got the B-type. And it was actually in this ratio. They had 50% of the time they had the B-type, and 50% of the time they had AB-type. And this was after several children, so you can make sure that those were the only two types in that ratio. They also tell that one of their B-type children married someone, so you don't know what that person is, but you know they married someone and made a son. Okay, they made a son who was O-type. So that's interesting. Now you have some information, and let's see if we can work backwards here and figure out what these parents, genotype of the parents were. Now, the easiest way to think of this is that we have to figure out that what is the blood type, the genotype here. Let's work backwards. Now, I know that this child is an O-type, so I know the genotype of this child is little i, little y. But if I'm little y, it means that I must have received an I for both parents. I mean, so whatever this parent is, it absolutely has a little I because I received that. And this parent also has to have a little I because it donated that. So I already have my genotype here. I know that one of the children have to be, one of the possible offspring of those parents has to be like that. Otherwise, you would never have that situation happening. I also know that genotype because I know that genotype is going to be like this, right? I know it's going to be both codominants, basically. So now I have some information, and I know that I get that 50% of the time and this 50% of the time. But of course, I could also perhaps get genotypes like this for the B type. So I can't make sure that that's my only possible scenario yet. But let's try to do a Punnett square and work backwards now and see if we can figure out the genotype of those parents. Now we know for a fact that 50% of the time you're going to get those AB. So I'm going to, just to save time, instead of using the I system, I'm just going to write down the genes as A and B or O. And you also know that there's going to be at least one child here somewhere that has the B with the O recessive gene. So you know that that's going to have to happen. But if this is the case, you know, for example, that this here has to be an A in order for this column to be an A. And you know that over here you have to have a B in order for this thing to happen. And you know that over here you have to have a B in order for this one to happen and this one to happen. But in order for this O to be here, you know that this one has to be a little I. And there you go. You figured out the genotype of the parents. And since you know the mother cannot be the A type, this cannot be the mother. And you know that the dad is going to be AO. You know, so the dad is going to be big I with the A. And then carrier for the recessive trait, which is why this son inherited the recessive trait, and then when he marries someone else, he made a recessive baby, and the mother is going to be pure B. And so, that you can see, you can work backwards from a problem and figure out the genotypes of the parents. It's actually very interesting. Now, in another problem like this, sometimes they will throw at you problems in which they tell you two different parents, who is the parent? You know, you can use like the Jerry Springer kind of thing. And you know, that's actually how they do it in Jerry Springer. It's much easier and cheaper than doing genetic analysis with DNA. That's only necessary if both of the possible dads have the same blood type. Let's see what, let me show you what I mean here. So in this particular problem, we know that Fiona is a B blood type. So we know that she's a B blood type and that she married or had sexual relations with someone that was an A type. And then we know that unfortunately she wasn't very faithful and she also married someone who was AB type. Okay? Now, one of the children, she had a child, we don't know who we're talking about, the child O type. Who is the daddy? Who is the daddy? Now, right off the bat, this is a simple one to solve. Because I know that guy over there cannot donate a little I. So there is no way that that's the dad. He can't be the dad because this guy doesn't have a recessive gene to donate. So we're talking about, in order for the child to be O-type, you think it's Fiona, probably is a carrier for the recessive trait, and this guy here is probably also a carrier, and that's what made that baby. But that parent cannot do that. This guy right there, Mark, is the dad. And so you can see how you can use blood types to figure out the offspring. Let's do another one. Let's see a little more complicated one to see if you can figure this out. This time again, Fiona, again, is a B blood type. And in a picture that is O type, which is an O type parent. And there's another guy in the picture that might be the possible parent here that we're talking about. And he is AB type. Now, in comes a child of the A type, who is the parent. Now, you don't even need a Punnett square for this one either, because how is this guy ever going to make a B child from if he doesn't have an A gene to give, and she doesn't have an A gene to give either, because she's a B type, and therefore this A gene must have come from that person. Again, the AB must be the parent here. All right, so see how that's easy to do? It's not that complicated. Let's do another one, see if we can figure that out. You have a mother, B type, and then you have a possible dad with that also has type. And then you have another possible dad with the A type, okay? Which is the parent if the child is AB? See, it's easy to figure this out. This guy here cannot donate the A. It must be that guy that made the baby. Because with these two collide, worst case scenario, you can have an O or a B, right? So that must be the dad. So you see, it's not that hard to figure these things out. Of course, you have to remember that blood types are not definitive paternity tests, because it doesn't necessarily tell you that that guy was the father. Just because he has the type that makes it work, it could be another guy, right? Another guy that we don't even know of that could be in the picture. So it's never determinative. But if you're trying to make it one versus the other, sometimes it will work out. But of course, sometimes you will have problems too. For example, that you have the same situation when she's the B type, and then you have a dad that's B, and another one that's A, possibly, and then the child comes out O. You can't really figure out this one, because let's say, for example, if this, for that child to be O, we're talking about someone who has the I recessive. But if everybody is a carrier here, any of the parent of the two of them could possibly be the dad, because any of them could have donated that combined with the mom's little I to make that child. So you can't make the determination based on blood type. So sometimes you can't really figure it out who's who. But anyways, that's blood type problems, and I have a challenge for you coming up on the higher level questioning test for this, and I hope you guys have fun trying to figure that one out.